So now coming to the next part, we are looking at the basic architecture of conventional IC engine. So it is a traditional setup. We have an engine, then we have clutch, transmission, and the power is transmitted to the wheels. So here the engine burns the fuel. It converts the thermal energy into the mechanical motion, but this process is very inefficient, which we can see from this particular diagram. So here first we calculate the well tank efficiency, which is around 84%. Now what do we mean by well tank efficiency here? So coming to well tank efficiency, we start from the starting point from where the petrol or diesel is being taken. So it is like from the raw crude oil, where we understand how exactly the petrol and diesel is extracted. So, coming to Weltag efficiency, it measures how efficiently is energy produced, processed, and delivered to vehicles tank. So, it covers electric energy extraction, that is from mining, drilling, oil, all this. Then it comes to refining of the crude oil, and then finally the transportation and distribution, where it is transported through a pipeline, and then it is included in the pump. That is our well tank efficiency. So it includes these process. One is where how the energy is extracted. So energy extraction. Then we have refining crude oil, refining crude oil, because crude oil cannot be used directly. It needs to be refined in order to get it into proper format, proper form. And then transportation. So all these efficiencies included to get the well tank efficiency. And when we do all this analysis, we get around 84%. This is a general efficiency. So once from the pump, it is given to the fuel tank. From the fuel tank, the IC engine converts the fuel into the mechanical energy using the thermal system, that is using the piston and cylinder. When the proper pressure is applied, the fuel is converted into the fuel initiates pressure within the engine, which leads to the mechanical movement of the engine. So this particular process has an efficiency of around 40%. But when we look at so that efficiency, we give it as tank to wheel. That is from tank to wheel, what is the total efficiency we get? So when it comes to diesel, we have around 20% efficiency, and then for gasoline, we have 17% efficiency. Now, once you calculate the total efficiency, diesel gives you around 17%, and gasoline gives around 14% efficiency. So where we can see that based on this, we can have a closer look that the IC-based vehicle are very inefficient. So most of the energy is lost as heat, friction, and sound. But beside all this, ICs are still common mainly because of widespread fuel infrastructure. And another reason why it is commonly used is long range. It has very long range, and also it is less expensive. So these are the main reason why the ICs are still common in the market. The next part here is the architecture of battery electric vehicle. So coming to battery electric vehicle, the layout is very simple. You have a battery pack which can store the electric energy. Then we have inverter which converts DC to AC. We have a motor which will drive the wheels, and then we have the controller which will control the entire power flow. There is no fuel tank. You can see here there is no fuel tank. There is no engine, and there is no gearbox, which actually increases the efficiency of the transmission system. So even here, when we try to calculate the efficiency, so this is the grid from where the power is being taken in the form of AC. Now, what is the efficiency of the grid? Now, it starts from how the electricity is actually produced. So if you have steam based or if you have any kind of power plant, how exactly the fuel is taken there, what is the efficiency of the fuel there, and how it is converted into electricity, all this is included. So here we have an efficiency of around 40%. So from there, the charger, which is used to charge from the grid to battery, here it includes AC to DC conversion. So this has an 85% efficiency. Then DC to AC inverter will have around 85% efficiency. Now, if you look at the total efficiency, sorry, total efficiency will go around 80% from well to battery. That this is well battery to wheel. Sorry, the battery to wheel, from the battery point to wheel side. That is this point, the efficiency is around 80%. So when you calculate total well to wheel efficiency, you get around 27%. Though it is very not very high, but compared to IC based vehicle, which has 17 or 20% efficiency, the 27% here is actually better compared to the other one. So the next one here is the fuel cell. So coming to fuel cell, here, the fuel cell are like battery EVs, but what happens here is instead of storing electricity in battery, they make electricity on the go using fuel cell. So here the hydrogen is stored in the fuel tank. So here the hydrogen is stored. Oxygen comes from the air, and inside the fuel cell, these react to produce electricity, heat, and water. Then the electric power, which is produced from the fuel cell, is used to power the motor, just like simple battery electric vehicle. The only emission is water vapor. That's it. But here, the hydrogen stations are rare, and producing hydrogen is also less intensive. So coming to efficiency calculation of fuel cell, they are highly efficient. So we start from well tank where the hydrogen is produced. So that has around 60%. So here the hydrogen gas is stored in the fuel tank. So the fuel cell are highly efficient in converting hydrogen to electricity. About 60% of the sorry, we start from this part. So here the hydrogen gas is produced. So that has efficiency of 60%. Then we have fuel cell, which can convert the hydrogen to electricity, and that has an efficiency of around 58%. Then from this part, that is from fuel cell to wheel, we have around 78% efficiency. When we calculate total efficiency, it comes around 27%. So both the battery and electric fuel cell based electric vehicles have better efficiency compared to IC based.